Hi guys, I'm back with another video, and in this video I'm going to show you how to create a homing missile and also the visual effects for the exhaust and also for the explosion. So I've already implemented this in one of the games that I created previously, and now I'm going to show you guys how to implement it. So now I have this empty 2D URP project open now. Let's decrease the gizmo size and okay, so now for the assets that I'm going to use these four assets. First is this spaceship asset that is going to be the enemy that we are going to target. This is the background, so it's for it to look better and to add some more originality to it basically. And then this is going to be our missile, and this is basically one of the effects that we are going to use. This is the particle that we are going to use, so that I'll show you later on in the second part. So first let's drag and put all of these in our project. So first and foremost, let's add the space background. It looks good. Now let's add our enemy over here. Now he's hidden behind the background because our ordering layer for both of them is 0. So let's turn this to 1 so that it comes in front of the background. And give it a rotation of 90 degrees. And reduce the scale to 0.2 for both the X and Y axis. So this is going to be our enemy. Now let's give the enemy a movement script so that he can move randomly, and then we'll create a missile that will chase this enemy. So to start with, let's create a script. Open the script. So first we'll add a parameter to control the speed of this spaceship. So public float and then we'll set a random target for this enemy. So at first we'll assign it a random target, and now we'll make the spaceship move towards that target. So if target is not equal to our transform dot position, let's move our sprite towards that position basically. So transform dot position is equal to transform dot position, which is our current position, and target is where we have to move, and now movement speed. But there will be an issue. We can't assign movement speed directly. We'll have to first get what should be the movement speed every frame. So first we'll calculate that. So that is going to be movement speed multiplied by our frame rate basically. So time dot delta time. So now we have how much the target should move in every frame, and it is going to move from our position towards the target. Now once we reach the target, then what we'll do is we'll set up another new target. Let's test this in the script now. Sorry, in the editor now. Okay, so our enemy is not moving. Why is that? So if target is not equal to transform that position, then we'll have to move him. Okay, so now we can see the enemy is moving within the screen area. Now let's create the missile and make it follow our enemy. So first let's take the missile, reduce the scale from 0.1. So as you can see, also to distinguish, let's change the color a bit to something that is more distinguishable. So let's change it to red. That is way better. Change 0.2. Okay, so now this is better. Now, one of the problems that we are going to face this sprite is basically for this particular calculation for following the enemy is that the general direction of the sprite is upwards, whereas we want it to face towards the right, and that is going to cause an issue. But I'm going to do it and show it to you guys so that it becomes more clear why we need to change the direction of the sprite. So let's first make the missile chase the target. Okay, so for that we'll have to add a rigid body 2D so that we can add 2D physics to this object. We'll make it kinematic as we don't want gravity to affect it, and we'll add a box collider 2D to this. And on the spaceship as well, we'll add a box collider 2D. Okay, so now let's attach our movement script for the missile here. So there are a few things that we are going to need here. First is what is our target. So what our target is going to be. Second is how much our movement speed is going to be. And third one is going to be our rotation speed. So this basically defines how quickly our rocket can change its angle basically. So we have a target, we have our movement speed, and we have our rotation speed, or I think to be more precise, angular speed. Yeah, this is better. So now first what we'll need is basically we need to find in what direction the rocket needs to move. Sorry, our missile needs to move. So what we'll do is first we'll find a direction. So for that we will subtract the position of this transform from the target. So basically in vector calculation, when you subtract to transform, it basically gives the direction pointing towards from our game object towards the target game object. So let's do that. So target dot position minus transform minus position. So this will give us the direction. Now the second thing that we need to do is normalize this direction. So what normalize basically does is basically converts the magnitude of the vector to 1. So basically doing any further calculation or multiplying it by a value becomes much more easier. So now that we have normalized our direction, let's add movement speed to our rigid body. So first let's get the rigid body component from our game object. So we have our rigid body now. Now let's add velocity to our rigid body, which is going to be so basically I've multiplied the movement speed with transform.right here. So transform.right basically means, so basically a transform can have two basically factors, the up and right basically. Right is basically is the direction in which the transform is facing, or you want to move towards. So when you do transform dot right, it's not in the whole context, it will always give you where the object is facing basically. So what we are doing is rb dot velocity is basically the forward direction into, so basically what this converts into is forward direction into movement speed. So this is our going to be our velocity. Now let's see how this works in our project. First, let's assign our spaceship as the transform target, and let's give 10 as the movement speed and 180 as the angular speed. But we have not used angular speed yet, so I'll show you after this. I just wanted to show how the velocity is working right now. So as we can see, it is just moving in the forward direction. Now let's first find what our rotation should be so that we face our target. So first find the rotation. So float rotation, and have to find it in the z direction. So float z, rotation z is equal to we are taking the direction in which we have to move and in what direction our game object is facing. So this is the direction that we have to move in, and what is the current direction that our object is facing, and the cross of where we have to face and where we are facing right now will give us the rotation. And we only want the rotation in the z-axis. So now we have basically the rotation. So from where we are looking to where we should be looking at. Now we have basically the rotation. So from where we are looking to where we should be looking at. And now let's go ahead and give this as an angular velocity to the rigid body. This is going to be rotation z into our angular speed. Let's go ahead and see if this works. So as you can see, there's something wrong with the maths here. The object actually is moving away from the spaceship and not towards it. And that is because the cross product that we got was actually in the opposite direction. So now what we have to do is basically turn the rotation into a negative so that now we can get the correct movement. Again, cross product is a bit complicated to understand, so I'll suggest you go have a quick look on what a cross product is. So now, as you can see, our spaceship, so our missile is following our spaceship, and we can assign different values to the missile so that it becomes more and more accurate. So if we assign 360 instead of 180, you can see it will become very precise. It will hit it very precisely every time. So again, you can play around with these values, whatever feels more natural to you. But still, there is one issue: is the rotation of this rocket. And as I mentioned at the very start of this video, was that since our sprite is facing in the upward direction, it will make it very difficult for this to work correctly. It should be facing in the right direction, because that is where we are doing most of our calculations from. So what I have to do is turn this sprite in the right direction, so that it looks more, it looks better. So what I will do is basically I'll create a child game object of this object. But if you already had a sprite that is already facing in the right direction, there shouldn't be any issue. But for this sprite, it's facing upward. So let's just change the direction. So I'm going to copy our again, you can't change the direction over here. Sorry, you can't change the rotation over here, because again our rigid body itself is controlling the rotation. So whatever rotation you add here will be overridden by our rigid body rotation. So that is why I'm creating a child. I'll add a sprite renderer to it and paste our missile over here, and I'll remove the sprite renderer over here. And now we have our missile, and what we can do is assign this child object 90-degree rotation so that it is always facing in right. So our rigid body will do all the rotation over this, and our child will always be fixed at 90 degree from upwards. So now See, this has also screwed up our box collider a bit, so let's just go ahead and fix our box collider. Okay, so this looks good now. Now let's try and see if everything is working fine now. Yeah, so as you can see now, the missile is following the spaceship every time. Now what we can do next is basically so as soon as our missile hits the enemy, it should explode basically, right? So let's add a on collision event over here so that we can add that functionality. The explosion part I will cover in the next video. In this part we'll just create the missile. It will go and hit the target and it will destroy itself once the target is reached. So now we have a missile, we have a spaceship, we have colliders on both of them. So now let's write the collision part. And let's turn the rigid body of our missile as a dynamic object and put the gravity scale as 0. So now this will trigger the on collision event. Let's see how it works. So as you can see, as soon as the rocket hits, as soon as the missile hits its enemy, it destroys itself. So now this is all for this homing missile part 1. In part 2, we'll see how we can add the boost effect and also the explosion effect once the rocket reaches its target.